Hello, what's up guys? Today we have another lecture related to fourth one. I actually break up the fourth lecture into few parts. The first part was about some signal processing basic concepts, and then we have gone through on spread spectrum, and today we will see wireless sensor network. So what is the wireless sensor network? It is interconnected sensor nodes. Let me get the pen. Okay, if you have those some sensors, so these are different sensors interconnected wirelessly. These are called nodes. So nodes that communicate wirelessly to collect data about the surrounding environment. Nodes are generally low power and distributed in an ad hoc, decentralized fashion. So remember, whenever we discuss IoT or wireless sensor network, we have 3 or 4 limitations. Number one, we have power limitation, we have processing limitation, powerful processing limitation, we have storage limitation, and so these are the limitation, and within those limitations we will play around. So although WSN, wireless sensor network, have gained a lot of popularity, but there are some serious limitations in memory, computing, battery life, and bandwidth. Wireless sensor networks can be defined as a self-organized and infrastructure-less wireless networks to monitor physical or environmental conditions such as temperature, sound, vibration, pressure, motion, and to cooperatively pass their data through the network to main location or sink. Alright, so all the networks, all the nodes, they sense the data and then send it via directly or indirectly to sink node. This is the sink node. Sometimes we say it gateway. Okay, if the node is directly connected to this, then it will send directly, or if there's no point-to-point connection, instead there are multi-point connections, then the data will go through with various nodes and ended up in sink. A sink or base station acts like an interface between users and the network. Typically, a wireless sensor network contains hundreds of thousands of sensor nodes. So the nodes may be in hundred or thousands, and they are self-configured, and whenever the only thing that to participate in the network is the network ID should be the same, and the pass key should be the same, and the role is also defined. If these 3 things any node has and they come into in the proximity of this, it will join the network. The sensor node can communicate among themselves using radio signals, so they can communicate with each other via radio signals. A wireless sensor node is equipped with, so every node is equipped with 3 things. Number 1, sensing or computing devices. and radio transceivers, power consumption. So let's take an example. This node might have a temperature sensor. It will sense the temperature, and on the board there will be some CPU that will process the data, and there will be some transceiver. Transceiver is the combination of transmitter and receiver. So from transceiver it will send data to sink or the closest node, and obviously there will be a power as well. This power could be a battery, possibly 1.5 or 3 volt or 5 volt or 12 volt, a battery, or it will directly plug into some power supply. Most of the time we use battery. The individual nodes in a wireless sensor network are inherently resource constrained. So we already discussed that the individual nodes are resource constrained nodes. After the sensor nodes are deployed, they are responsible for self-organizing and appropriate network infrastructure, often with multi-hop communication. So in ZigBee or XBee, it has the range of this would be I'm not sure, is it 10 meter or 100 meter, but anyway, if this is, we take it the 100 meter, let me make sure. Okay, so the module, ZigBee module or XBee module, if it has the range of 40 meters, if it is indoor, and outdoor the range is 120 meter. So the sink, let me take pen. So if the node and sink, the distance between these two is 40 or within 120, and it is outdoor, there is no need a third node. There will be connection, the connection would be point to point. But if a node is placed at a distance that is greater than 120, then there will be a middle, there will be some other node in the middle of sender node and the transmitter, and then it forms a multi-hop communication. The last thing is that the working mode of the sensor nodes may be either continuous or event driven. So what does this mean? This means that if we have this sensor and it needs to send the data to sink. When this sensor need to send the data, so it says there are two types, continuous and event driven. The continuous means it will send data continuously, like for example, you are watching a live match, so the data is coming continuously. The another one is the event driven. Event driven means whenever some event occurs, the sensor will send the data. For example, the temperature sensor, we manage it in such a way that if temperature, the current temperature is, let's suppose, 15 degrees centigrade, when there is a change of 5 degree plus minus, if there is a change of 5 degree, whether it comes to 20 or it comes to 10, At that wireless sensor network enables new applications that require non-conventional paradigms for protocol design due to several constraints. Obviously, when wireless sensor network emerged, the applications running over this was diverse applications. Owing to the requirements of low device complexity together with low energy consumption, a proper balance between communication and signal data processing capabilities must be found. Nowadays, most of the research is going on wireless sensor network to consider the efficient energy and efficient computational algorithms. So researchers are working on those things. These are the very hot topics. You can see there is the range of frequency. This is the spectrum. So if we have a range of frequency, for example 400 to 1500 hertz, we have frequency hertz. How many total frequency would be here? There will be, I think, 1100 hertz. Rather than processing single hertz, we can divide this into from 400 to 425 and 426 to 450 and divide them. This is called bands. Okay. IEEE 2.15.4 is an efficient standard for MAC protocol. Synchronization header is added at the first of any frame, so this one is added at front of the frame. The SHR consists of 4 bytes, so it has 4 bytes preamble sequence and 1 byte SFD. So 4 bytes of preamble sequence and 1 byte of SFD. These two fields are set automatically by the hardware. In the PHR physical header, the length of MPDU is written. The SHR and PHR are placed at the physical layer of 802.15.4. The radio has FIFO memory with 128 bytes capacity. So FCF frame control field. Let me take the pen. Okay, this is FCF frame control field and data sequence, address information and frame payload. So when you know the payload, if the temperature sensor send a temperature of 23, so this will be sent in a frame and the 23 will be placed here, and the rest is just the protocol that can show that where the frame sequence, what is the frame sequence number, where it is destined, from where it is originated, and some checksum for checking the errors, etc. The frame control, sequence number, destination, personal area networks. This is the network ID and destination address. This is source network ID, and this is the source address. Frame payload, this is the actual data, and frame checksum. Frame control is itself 2 bytes, and these are the 2 bytes. Number 1 is frame type, security enabled, frame pendings, acknowledgement request, interpersonal area network reserved, destination address reserved, source address, etc. And frame type, that shows that what type of frame is this. we're gonna read that how many types of frames in the IEEE 2.15.4. So the one type is beacon, and there is a data frame, acknowledgement frame, MAC command, and reserved. We have those frame types. The MAC layer defines two basic modes. So MAC layer has two basic operation modes, beacon mode and non-beacon mode. This is beacon mode, and the beacon mode is actually the delimiter of supraframe. Means supraframe comes in between two beacon frames. The beacon defines the start of a superframe, which is basically the interval between the beacons. Beacon is used. So what is the purpose of the beacon? It is used for the device and the network to synchronize with each other. Beacons are only used when a device is first turned on. So let's suppose we have an XB, and it is connected with and there is a temperature sensor, and there is an Arduino. In Arduino there is a XB. So when you turn on this XB frame, and when you turn on this XB device, the frame it sends in the beginning are known as beacon. This is for the network management. It will scan for the network for other devices. And the super frame is divided into two parts: active time and inactive time. You know that the end devices or the router or WSN nodes, we have a limitation of power. So if those devices are active all the time, they will suck off the battery in minutes. So to save the battery, we need not to keep them active all the time. They should only be active when they want to send some data. So we will do to sleep those nodes, and that time is called inactive time. And active time, there are two types of there are two things. One is contention access period. This is a contention access period. This means anyone can send data at any time if it is cap. The only thing is that it has to follow this CSMA CA. It should listen the media. If someone is sending the data, then the device should wait. If no one is sending the data, the device can send at any time. But in contention free period, we have given slots to nodes. So whenever a node has slot, it can send data. It doesn't need to do CSMSCA to check that someone is sending or not, because the slot is allocated for a certain period of time. Okay, non-beacon mode is completely asynchronous. So asynchronous means, as I told you, that if this is if this is a device, a child device. So two types of device. One is the parent one, other is child, or you can say one is coordinator, another is end device, or you can say one is full functional device, FFT, another is, I think it's is full. What I forgot, but I will tell you that there is one is full functional device, another is not full functional device. It just okay. So this device is a child device, and we want to keep this device active and inactive. Whenever it want to send the data, we will make it active, and whenever it is idle, we need to put it sleep. Okay, so if this device is sleeping and some packets arrive to parents that is destined to this, the parent will not send it to child, it will rather store here. This is called asynchronous mode. So when the child wake up, it will poll the router, poll the coordinator or parent device that is there any packets for supposed to this child, and if there are some packets, those packets will be delivered. As I told you, there are basically four frames. One is beacon frame. The beacon frame is a special frame that is used to transmit network information and also synchronize devices on the network, and can only transmit it by full functional devices. So beacon frame can only be sent by this device, the device that is full functional device. In ZigBee, the beacon is used to transmit network information and is only used for network discovery. So the frame is mostly the frame is same as we discussed in previous slides. There is FCF, frame sequence number, and network ID, and source address ID, and super frame specification. This is not used in ZigBee, and we are particularly focusing on ZigBee devices. And this is beacon payload frame checksum. Another frame is the data frame that is used to transmit data, and that can be sent as unicast or broadcast. Unicast and broadcast, you know what does it mean. Command, this is the third type of frame, and that is used to send, sometimes we need to send commands to the nodes. So these are the command types. The rest is same: FCF, sequence number, network ID, destination address, source network ID or source destination address, and command ID. This is the command payload. Command ID, association request. It could be association request, association response, data request, PAN ID, personal area network ID, conflict notification, orphan notification, beacon request. So if these are, if here in command ID we have 05, the hexadecimal 0, hexadecimal 5, this means this is a personal area network ID conflict command. Acknowledgement: when a frame has set acknowledge request flag, this means that this frame needs an acknowledgement. So when sender sends that frame with is acknowledgement request flag is set, then the receiver must respond, acknowledge it to sender. So this is the way to say that the frame has been successfully received. So two types of addresses are here: extended address and short address. Extended address is 8 bytes, 64 bits, and the 24 bit is organizational unique identification, OUI, and 40-bit is the company ID that owns OUI. And short address, 2-byte address, this is the address that use wireless sensor network nodes to send data to send data to some nodes. This short address is used to identify the destination. Thank you very much, and see you soon with the last part of the 4th lecture. So be safe and stay at home. Bye. Thank you.